Welcome class to 11-1A. Today we're going to move on to simplifying rational expressions. So again, our objective, we're going to be working on factoring and then simplifying these rational expressions. Little bit of review first. Before we start reducing rational expressions, let's talk about reducing fractions. All right? So 15 over 35. How did we learn to reduce this? Well, we learned to reduce this, simplify this, by looking at 15 and saying 15 is 3 times 5. We look at 35, and what is 35? Well, 5 times 7. So what did we learn to do? Well, the 5 is the same on the top and bottom, so we learned we can cancel it out, and we're left with 3/7. So that's how we end up reducing fractions. And the cool thing is we can actually reduce rational expressions the same way. What I mean by rational is two polynomials being divided. Okay? So that is a rational expression. Two polynomials that are being divided. So we've talked about basic fractions. Now let's talk about some more complex fractions, some true rational expressions. So number 2, now we're tossing in some variables into there. All right? So looking at this, in order to simplify this, in order to reduce it, what I'm going to do is I'm going to break everything up. So remember, in number 1, I broke up the 15 into 3 times 5. Now, x cubed is x times x times x. 35 is 5 times 7. Then x squared is x into x. So what ends up happening? Well, those 5's cancel just like they did before. But now so do x's. So that pair of x's cancels. That pair of x's cancels. So now what do I have left? Well, on top, I have a 3x left. And on the bottom, I have a 7. So reducing something like that is essentially exactly the same as simplifying a normal fraction. All right? Expand everything out, slash out anything that's the same. However, you do have to be careful. Here we were talking about two monomials. Okay? Two monomial expressions. And again, monomial expressions means a single term. You have two single terms dividing. What about this? Well, this is not two monomials being divided, okay? That has some addition and subtraction going on. So whenever you have addition and subtraction happening in the fraction, you don't want to do that, all right? So again, whenever you see addition or subtraction, you do not do that process, all right? When you have addition and subtraction, there is a magical answer. The answer is the reason we did our pre-11 notes yesterday. The magical answer is factoring. All right, you absolutely must factor whenever you see pluses and minuses. Your answer, factor it. All right? So, if I'm going to factor this, 2x minus 6, the top of my fraction, notice that there is a 2, or that 2 can divide both of those expressions. I can pull a 2 out of that. So, on the top, I'm going to factor out a 2. So that's going to be 2 times x minus 3. The bottom can't be factored. So I'm just going to leave the bottom as is. Now, the key to simplifying this, once it's factored, now I look for parentheses that can cancel. So notice here, I have that x minus 3 on top and x minus 3 on the bottom. So I take that whole expression, that whole parenthesis, and cancel it. And all I end up being left with is 2. So again, that's the key to these. You have to factor, then cancel those parentheses. All right? So number 4, again, our magical word, the word you just can't get enough of, factoring. So on the top, notice, it's a quadratic trinomial. So to factor that, I know that I'm looking at my 2 parentheses. Notice here, the a term is 1, so x squared comes from x and x. Now, I'm looking for 2 things that add to 8 or that multiply to 18 and add to negative 11. Again, how do you multiply to be positive, add to be negative? The only way, 2 minuses. Now, what combination works? That 18, we can have 1 and 18, 2 and 9, 3 and 6. Well, the one that gives you that negative 11x is going to be minus 2 and minus 9. All right, on the bottom is another quadratic trinomial with the a term being 1. So that's going to be your nice one, x and x. So how do we get 8? Well, 1 and 8, 2 and 4. Notice we're talking about a negative 8. How do we deal with a negative 8? Well, to multiply that, we're going to have a plus and a minus. Which one will give us a positive 2x? We have a positive 4 and a negative 2. So now, once I've completely factored this, now I look for one of the parentheses that is the same top on the bottom, and I'm going to cancel it. So x minus 2 cancels off. So I'm just left with x minus 9 divided by x plus 4. Moving right along, looking at number 5. So this time we don't have any quadratic trinomials. So I'm not going to be looking at canceling things using parentheses or factoring things using those parentheses. However, look at the bottom. So what factors out of the bottom? Well, I see a 10 pulls out of each of those terms. So when I factor 10 out, I'm left with x minus 1. Now, on the surface it may look like, well, there's nothing that's the same. However, notice the 2 numbers, all right? After I pull out that 10, what I'm going to notice is 15 is really 3 times 5. That 10 is really 2 times 5. All right? So when I think about those 2 numbers that way, notice my 5s are going to be able to cancel off. So when I cancel off my 5s, I'm left with 3 on top, then I'm left with 2 and the x minus 1 on the bottom. All right, moving right along. So, kind of the key here is it looks like we factor first. You have to factor and then re-reduce. Or by reducing, you can also think of that as canceling. Canceling anything that is the same on the top and the bottom. All right, looking at our next example. So, this next one, when I look at the top, the first thing that I'm going to notice that 3r squared minus 39r plus 90. The first thing that I notice, a 3 pulls out of each of those. So I'm going to pull that 3 right on out. So that's going to leave me r squared. Negative 39 divided by 3 can leave me negative 13r. 90 divided by 3 leaves me with a 30. Okay, and then for now, I'm just going to leave the bottom in this step. So now I want you to notice we have two quadratic trinomials. So that means now, after I pull out that 3, now I'm going to start breaking everything down into the two parentheses. That's how we handle quadratic trinomials. So on the top, r squared minus 13r plus 30. Again, that r squared has an a term of 1, so that means this is going to be one of our nice cases. That means we're getting r and r, and now we just focus on the 30. So 1 and 30, 2, 15, 3 and 10, 5 and 6. Now I want you to notice it's multiplying to positive 30, and yet it's adding to negative 13. So that means, remember, we're getting two negatives. And what two negatives work? Negative 3 and negative 10. Those add to the negative 13 that we're looking for. The bottom one, r squared minus 3r minus 70. That, what we're looking for, again, the a is equal to 1. It's our nice simple case. We're just getting r and r. And now we worry about the 70. So things that multiply to give us 70. So 1 and 70, 2 and 35. We get 5 and 14. We get 7 and 10. So those are the combinations that multiply to 70. Now again, make sure you are aware when you're factoring, you remember it is a negative 70. So that means we are dealing with a positive and a negative. So which of those can, when we add them together and make one of them negative, do we get a negative 3? Well, if we have a negative 10 and a positive 7, that'll give us the negative 3 that we're looking for. So now that it's completely factored, now what you need to do is cancel anything that's the same top and bottom. So I'm going to cancel these parentheses of r minus 10. So what I end up being left with is that 3 and the r minus 3 on top, and then the r plus 7 on the bottom. That is my final answer. So thank you so much for joining me for these notes. Again, please make sure you have all this written down to come to class prepared to do the practice work tomorrow.